Hello, everybody. Welcome to a new video interview with the 3D food printing experts of the world. Today, of course, co-hosted by the BotBQ and 3D Cooks. Joining us from Frankfurt, Germany, we have Jason Mosbrucker. Hello, Jason. And myself from 3D Digital Cooks, Luis Rodriguez from Barcelona, Spain. Really happy and excited because I'm fan of his work. Today we have none other than Jeffrey Lipton from Cornell University in New York. A pleasure to have you here with us, Jeffrey.
Thanks for having me. It's a pleasure to be here.
So I think everybody should know about you already, but for those who are a little bit lost, or they just they are just starting in this awesome world of 3D food printing. What can you explain us? How could you explain about you, or tell us about you? What do you do? How do you?
So I am a PhD student here at the Cornell Creative Machines Lab. For the last few years, I've been running the Fab at Home project out of Cornell. I, in fact, started it with the Fab at Home project in 2009 and took over it in 2010. And since then, we released the Model 2 and Model 3 Fab at Homes and published several papers on food printing. I love to say I started food printing here, but I actually just came into the lab, and food printing was a small part of what we did. But in my tenure here, we've turned it into a large part of some of the research we've been putting out in the 3D printing space. We've done work with the French Culinary Institute in New York City. We've done work a lot with the hotel school here, and we're doing some collaborations now with the Food and Brand Lab here at Cornell, focusing on how 3D printing can be useful in the short term and the long term, and kind of mapping out where food printing should go and what technologies need to be developed.
Cool. That's my personal question. So your PhD is related to 3D food printing?
Yeah, so about a third of my PhD is going to be on food printing. We actually just settled on the title a couple weeks ago. It's now going to be called 3D Printing Food, Foams, and Forces. So there's a lot of ands, and we went for the full alliteration. But about a third of the papers and a third of the overall content in the thesis will be based on food printing.
Really cool.
That's awesome.
Yeah. It's been pretty good. It's nice when you can, go out with a P card and order a whole bunch of stuff at the local grocery store and not get questioned. It raises a lot of eyebrows when you come back with a grocery list as your lab supplies in the mechanical engineering department.
That's cool.
So let's go a little bit at to the beginning. How did you started printing food? So what you just told us, you got involved with the Fab at Home project, 2009.
Yeah. So the Fab at Home project got involved with food printing kind of by accident. In 2005, Evan Malone, then PhD student, now Dr. Malone, was working on a 3D printer that could be assembled by anyone. And basically the premise was Hod wanted a printer that was cheap enough that he could let an undergrad play with it. Because up until that point, we had built our own 3D printer, but it cost $40,000. It was very sensitive. And so Evan designed one that if an undergrad broke, we wouldn't fire the undergrad. And that was Fab at Home Model 1, which was released in 2007. And he gave the designs away for free online. People started building them. And when they were done putting in silicones and epoxies, they looked around their house and said, what else do we have that we can stick in this machine? And they started putting in Cheese Whiz and Nutella and peanut butter. And we collectively smacked our heads and said, oh, why didn't we think of that? So the first paper on 3D printed food I can find is from Dan Perriard, Evan Malone, and a high school student named Noy Schall, who won her high school science fair by 3D printing chocolates on a Fab at Home. And it would involve 3D printing chocolate, 3D printing with Cheese Whiz, 3D printing with frosting for both support material and for build material. And it was published at the Solid Freeform Fabrication Symposium in 2007, I want to believe? No, 2008. 8 or 9. And we had done that, and the project was kind of kicking around. And so when I joined the project in 2009, we were playing with this idea of what we could do, but we'd run into a problem. And the problem we ran into was what we called material set bloat. That every time you calibrated a material, you had to calibrate it, and then the temperature would change, and you'd recalibrate it, and then something else would change, and you'd recalibrate it. And so I was brought on to help Dan Cohen solve this problem, and we started working with it, and we came up with this idea of, wouldn't it be great if we could do an RGB color palette for food? So we'd only calibrate these materials once, and we would just assemble the materials together. And so we published a paper on that at Solid Freeform Fabrication, and it worked. You know, we started with this premise of, well, the flavoring industry can make anything taste like anything. The coloring industry can make anything look like anything. So all that's left is texture. How hard could it be? And we started making things on the 3D printer with different textures using gelatins and additives, and it worked, but it was universally condemned as the most vile and disgusting things that people have ever seen or heard of. There was just this huge rejection of it. And so on the flight back from presenting that work, I read a paper. I was actually reading Popular Science, and in it, David Arnold was talking about his work with molecular gastronomy, and he mentioned he happened to want a food printer. So as soon as we landed, we called him and said, "You want one?" And ever since then, we've been working on printing real foods out of a 3D printer and borrowing techniques from molecular gastronomy and bioprinting to do that, rather than trying to, you know, make completely synthetic foods from the ground up and completely processed. We've kind of switched our direction, and so a lot of my work has been on what processes need to be put in place to do that, and what new technologies are enabled by, you know, 3D printing of food directly.
So that's one question I had, and thanks for that history, Jeffrey. You guys must have been focused a majority on actually structuring food that can be printed in, I don't know if I'm saying this right, but exactly that point that you just mentioned, when you switched it from actually synthesizing food to be printed or creating food to just focusing on printing food. And I guess what specifically drove you to that change?
User reviews. Right? There's only so much you can get an undergrad to do for an A+ to sit and taste. And we got there's some. We were getting a lot of feedback on it was just, you know, it's just not good. And so we went back and we said we need to make food that tastes good. And actually, another part of it was later that year, after we did the work with David Arnold, we were starting to get feedback of this feels too processed. So we wanted to say, all right, how can we market this idea of food printing so that it feels less processed? So me, Hod Lipton, and Dan Cohen got together and we started to think about it, and we partnered with Franz Nigel. So here we're 3 Jewish boys and an Austrian, and we came up with the most wholesome thing we could think of was Christmas cookies. And so we decided we were going to print Christmas cookie recipes out of a 3D printer so that it's the least threatening thing possible. We made them organic, you know, locally sourced all the ingredients, and 3D printed them just so that all people had to deal with was the 3D printing aspect of it, and not kind of run people down, you know, all the infinite possibilities because we were afraid that they would reject it. And it was a little prophetic because a couple years later, there was this problem with pink slime. Right? You know, there's all these companies were shut down in the United States because the term pink slime was associated with certain products that were produced from meat. And so we were like, we need to market this concept. And that's really what we're doing, is marketing a concept of 3D printing food. And so that's kind of focused our work down on, we need to make it wholesome, as wholesome as possible so that people aren't scared off by it.
Yeah, no, that makes complete sense.
Yeah.
I think that was I don't know who's going to take that next step. I think there's some scientists over in UK who are really focused on that aspect. But I think that as far as the marketing aspect, you probably made the right decision there, or else you would have had no undergrads applying for to come and work for you. I guess then other word would have got out pretty quickly.
Yeah, there's a lot of truth to that. Actually, I remember who is it? Someone in the UK, Susan Storrs, I believe is her name. She did this 3D printing insect paste called
Yep.
Insect au gratin, and she had reached out to us to use a fab at home for her machine, and we begged her not to do it. Not because we didn't think it was a good idea, which is neither here nor there. It was just like we didn't want the concept of 3D printed food merged with the concept of eating insects in the public mind,
Yeah.
because if it got merged too soon before either of them has been accepted, the odds of either of them being accepted is lower.
That's a funny story, but it's
Yeah.
so true. I mean, early technologies can really they either disappear really quickly with that type of stuff coming out, or they either shoot up like a rocket. And I think you made the best bet there. Whatever happened with her project?
She did it. She did it. Ended up doing it with inkjet-based technologies, where it was powder that she jetted down on top of, and she made beautiful sculptures out of insect powder. I don't know if anyone ate them, but it's part of the allure that she had for it. And you find this a lot. There's kind of three different communities inside of the food printing world. I call them top-down, bottom-up, and bio-inspired, right? And they kind of have different concerns that they come from. You've got the bottom-up people are like where I started with, let's make food from the ground up, and start with very simple sourcing things like insects and other things, and put them together. And they really have this Malthusian concern that we're not going to be able to feed the world, and therefore the only solution is to 3D print from efficient sources, so we can simulate traditional foods with completely artificial or completely different sources. I think it's hard to do. I think it's hard to market, and I'm not really that concerned. I'm not a Malthusian in that way, so I don't subscribe to it. Then you have the bio-inspired people who are like Modern Meadow, who I have to give a lot of credit to. They're doing some great stuff, and they also have this Malthusian concern of not being able to feed the world, and they're just trying to use bioprinting as one of their techniques to drive the cost of synthetic meat without a kill down below 10 cents a pound. They're a couple orders of magnitude off on price, so it'll probably be a couple decades before they hit that, and that's regardless of their marketing, but of the idea. Eating meat from a petri dish doesn't seem that appealing to a lot of people, but if it's eat meat from a petri dish or don't ever eat meat again, we'll see what people decide.
That's right.
But really the one that's getting a lot of popularity right now is the top-down, and it's the one we've resubscribed to, which is the take real food, print it, and use the printing process to make the food better. And I think it's the one with the most short-term impact and probably medium-term impact. And it really just comes down to wanting better artistry in your food. The leaders in that right now are 3D Systems with their sugar labs. They can do some of the most beautiful sculptures in the world out of food. And then in the longer term, we're pushing this idea of customized nutrition, that by automating the food production process, we can bring in big data, and then your hamburger isn't your hamburger. Your hamburger is the concept of a hamburger plus all the data about you and all the raw ingredients. So that's your burger for you. And I think that can have a lot of long-term impact, but you have to build a lot of systems in place before that'll be useful.
Yeah. That's something I actually talked about that point right there back at the the FabCon last May in Erfurt. I think it's going to get to that point, and I don't think it's. I don't know a timeline, but I think it's going to get to that point, and I think all those things you just mentioned, where it's either eat petri dish meat or don't eat meat, at all, and there may not be any chicken eggs around. I don't know what's going to happen, but I think all those points are definitely valid, and the more I delve into 3D or food, and learn more about food and our world, and I think that food printing is just gonna grow and grow and grow.
Yeah, I think it's going to be really good, from the very point of view of just waste reduction. If you produce food on demand, portioned properly, you reduce a large amount of the waste that's being done in our food industry, because most of the food that's wasted is done at the last step, right? It's you over
Yeah.
prepare food and you throw some out because it spoils. And being able to reduce that because you prepare just the right amount would have a huge efficiency impact. And we see that in other areas of our production system. It's just, everyone, and especially with 3D printing, everyone wants to talk about distributed manufacturing and how great distributed manufacturing was. We've kind of given up that idea as a community for right now because 3D printing's not there. But with food's already distributedly manufactured. It's one of the few products that is majority distributed manufacturing.
Yeah.
And it kind of makes sense to improve and add automation at a small scale for distributed manufacturing of food, which is how we do it now. And big data is coming for everything. I talked to the hotel school across the way, and that's kind of where they're starting to think now is big data, big data, big data. It's coming for all aspects of the hospitality industry, and food is one of them.
Well, I can see before too long you're not going to be able to order at a restaurant without clicking a TOS agreement. You know what I mean? Giving up. I can see it. I mean, I was just in Paris, and I swear every time I went, I did anything at the hotel. It was check here. Anytime we were at, it was just it's everywhere. You're giving up. The data's, you're right, it's coming for you, and it's eating everything, and I think I can't agree more with that. The data's coming for you.
Well, the other thing is, so we were talking about this at the hotel school a couple weeks ago. Labor, right? Labor is a huge component of costs in the hospitality industry, food production specifically, and there's a huge movement now increase the cost of labor. And that will probably drive a lot of people towards automation because most of these jobs are things we can automate already. It's just you're cheaper than a robot. Yeah. And I forget the name of the company. I was just talking to one of their advisors. There's already a company that can produce hamburgers completely automatically from beef or lamb sources and automate the hamburger production line at a fast food restaurant. It just happens to cost like a couple $1 million to build their machine. Well, you drive up the cost of labor high enough, the machine becomes cheaper than the labor, and all of a sudden now every McDonald's is basically a giant robot factory with an app. Then integrating data into an automated system becomes really easy, and food printing itself may be part of it and part of the customization aspect of it, but it's going to be part of a larger ecosystem of food automation and food production automation.
Yeah, no, that's right. Even here at the local McDonald's in my place, they got the touchscreen order systems, and the only time you talk to anybody, if you want to, is to actually go up there and grab your bag, and that's about it.
Yep.
It's all. That's it, and I hear they're having that over there in the States too here pretty soon. So it's coming. Yeah, labor is definitely a big thing. Automation is something that is scary for those type of workforces.
I think it's really interesting what you guys are talking about. Like, I guess everybody involved in 3D food printing has had the same conversation with people, like explaining what it is. They get the idea of the replicator machine, and then trying to explain how things work now. So I'm really curious. Like, okay, I'm sure we all three agree that we will have replicators. Maybe not us, maybe our kids, but I would like to get your thoughts, Jeffrey, about how do you picture how we can get there from where we are now, and especially because you have already a experience, a background from a few years already working on the field. So we know you know how it has been, how it had evolved for maybe 6 years already. How do you we can get there, or the next steps in technology terms, let's say?
Sure. So I have to premise with saying I'm not sure we'll ever get to the real Star Trek replicator from Next Generation, but the food service station from the original Star Trek, we're heading for that real fast. You know, that magic door that your tray comes out of and everything's prepared and there's some robot behind the scenes, definitely coming. I think the next steps is it really depends on what industry level you're talking about, right? You kind of have to segment it out by industrial processes, bakeries and restaurants, and personal use. At the industrial scale, 3D printing just needs to be faster. It's just too expensive to 3D print pretty much anything at an industrial scale. So I don't really see it being useful except for in kind of niche, high-value cases. So I think the best one that anyone's come out with so far is the BioZoom work out of TNO with smooth food replication at an industrial scale using a 3D printer because it's a high value added in the food. At the bakery level, it's really, I think the limiting factor is cost right now there, that, a 3D printer from 3D Systems costs $10,000 for bakery. That's just too much expense for a capital piece of equipment that's more expensive than their industrial mixer. So that needs to go down in price to the bakery. Now, it may be done through a business model. So it may be done through, giving away the printer and charging for the sugar, which may be the way to do it. But either way, the cost up front to the bakeries needs to be lower, and also the skill barrier that chefs right now don't know CAD. That's going to be the biggest limiting factor in terms of getting good artistry in places. It doesn't matter if you have a 3D food printer in a bakery if the bakery owner can't use CAD to make the better artwork. So education is going to be an important area there where you kind of have to start, and 3D Systems is doing it. They're starting to put it into educational bakeries. At the home level, aside from cost being the biggest factor, there's also a need to develop parametric recipes. And that's something we've started to explore, where it's not just 3 eggs, 2 of this. It needs to be a computerized function of how the recipe works, and all those things can limit your 3D printing. So we just published a paper where we showed we did 2 cookies that were completely different caloric level based on 2 people's BMI, medical information, activity levels. But we could only vary certain parameters so much because there is a window of butter, right? If you increase butter too much, the print process fails. Decrease it too much, print process fails. So kind of mapping out what are the design spaces of recipes is going to have to be the next step for 3D printing food if we want to do it with really open-ended design where people can input information and get out a custom item. So I think that's a big technical barrier, and that's going to be very labor-intensive in terms of developing these recipes that are parametric. I think the other barrier is going to be developing shelf-stable recipes that either people can buy as a cartridge or really bringing the price the price down and the speed up, because those cookies took a half hour to print one, which is great in concept in the lab. It's TRL level 3. It's not TRL level 9. And speed and cost are really the 2 big limiting factors on everything.
Can people find this paper? Is it out there?
Yeah, I think it just went and published. It was in Trends in Food, Science, and Technology. So I'll see if I can paste you guys the link.
That'd be great.
Here we go. So they changed the title is now Additive Manufacturing for the Food Industry. And so we talk in there about the different methods and applications and technologies and the parametric design limitations we ran into with cookies specifically. How we had shape stability issues that came into effect when we started messing around with the nutritional values.
Great. Thanks
Yeah.
for posting
Great.
that.
I think I'm something that I've been really curious about. Obviously, I'm a Dave Arnold fan. that
Who isn't?
that need to be said. And one of the things that I really appreciate from the work that you have been doing is that you have taken the printer to the kitchen and you have been working side by side with cooks or chefs, and through going to battle is how you learn. No, I think everybody is aware already about the design limitation, not because chefs are stupid, because designing is too complicated right now for anybody. I think at all sorts of levels. So I'm really curious about how is the reaction, and then beyond that, how you manage to work together in order to make these new recipes evolve. Obviously, they know a lot more about food processing or dishes and food pairing and so on. What is your thoughts about it?
Well, I'm pretty lucky in the sense that I've been working. I get the luxury of working at a very low TRL level. For those who don't know, in the audience, TRL means technology readiness level, right? How close is it from concept to reality? And the Department of Defense uses 9 levels. 1 from I wrote a paper about the idea, 3 being I've proven it in the lab, 6 being I've proven it in similar conditions, and 9 it's deployed widely. I like, and I have been working at low TRL numbers of 2 and 3, where we have ideas, we just test it out, we have to get it to work once. So with them, it's been more about a little bit of back and forth of it needs to have this property, we kind of tweak it, and then we just kind of force the machine to get it to work so that we can get the one example or a couple example units out so we can extract the data. Other people, I think, have a very different approach to it, and especially the more industrial ones, because they have to go and really characterize everything and develop a complex process that's well understood so that it can become reliable, repeatable, and efficient. So in working with the chefs, it's been more back and forth, being in the kitchen, mixing something up, putting it in a syringe, saying, it's too soft, it's too this, as we go to print it until we get it just right, rather than trying and perfectly characterizing the material and understanding the process completely and then going out and sticking it in the printer. So I've been pretty fortunate to work at just, proof of concept level 1 or 2.
That's great. What else? Jason, go ahead.
I think that designing is going to be one of the biggest factors that's going to make or break food printing as far as getting into the home kitchen. And I'm pretty sure that chefs and those type of people won't be doing it. Just from knowing a few, I know my wife, she's an amazing cook. I have a couple other friends that are cooks, and I just don't see them taking the time to step out and go into a design class, a 3D design class or anything like that, or spending a lot of time learning these type of things. And I don't know if it's going to be a specific job, a new job opening up, food design or 3D food design, something like that. But I can definitely see some consultations, and I think that making the designs parametric, like you said, and easily accessible and interchangeable with recipes is important. But do you think that there'll be more jobs than just manufacturing the food printers and things like I don't know. So we would call it. So Lewis, to me, he's like a digital cook. But do you see jobs opening up? Or maybe I should rephrase it. What type of jobs do you see opening up in the food printing? I don't know if it's an industry or what do you consider it?
Um, hmm. It's kind of hard to say. Uh, it's very hard to predict anything, especially about the future. It's one of my favorite quotes. I forget who said it. Um, in general, in terms of the job aspect of it, you kind of are looking at how do food scale? And right now, if you're a chef coming up with a recipe in your kitchen, you just kind of experiment and you get it, and then you kind of refine it a few times. But bringing that to an industrial scale food process right now requires teams of people to develop the equipment and figure out the process exactly and characterize it. It's what all of these mega corps who buy grandma's recipe and start selling it to, and they bring a whole bunch of jobs along the way. If food printers are in everyone's kitchen, and food printers are that robust that they can produce a large number of things, then it's you're basically saying, well, what happens when you have iTunes? Who's going to make the apps? Someone may have an idea for an app right now, and comes along and hires a bunch of people in order to take their basic outline and sketch and turn it into something that can be marketed and sold. So in terms of doing the same thing for food printers, will probably be similar, where someone has a great recipe they made once, and then they hire people to help turn it into a parametric program that can be uploaded to food printers, or design the cartridges that can go into the food printers. So I think you're going to still have those same scaling issues of how do you take a good one-off and turn it into mass reproducible parametric design. It's going to take a lot of labor from a lot of different skill sets.
Yeah, because I think it's also hard to predict, and I kind of dream about, and I have I imagine a design, a food design chef, or a food design, I don't know what the word is, but an assistant or something like that.
Right. What we need is food.
I'm thinking a food what?
Food CAD for food.
Food hacker. Oh, food CAD. Yeah, that's exactly what I'm pushing Lewis to get on. He's already designed an app. I don't know if you've seen it, but it's specifically designed for food design, and it's a web app. Lewis, you want to post the link in here in the chat? Maybe anybody wants to check it out. But it's a really cool design. It's just basic, simple stuff that I think you enter in some parameters and it gives you your design. It's not too complicated or anything like that, but it's really cool. And I think scaling something like this that he's already worked on would be the next step. But I always envisioned this type of 3D food designer in the back office, in the kitchen or something, pumping out designs. And I don't know, maybe that's a little bit too futuristic in the future. But
or you can think about it, one of the things you're going to have to do is really characterize the foods, right? So you come up with your recipe. There may be a service that you go to that says, give me my print, parameter characterizations as a function. You send them off 10 samples, and they give you back an equation. We already have software out of this lab here where if you give it raw data, it'll give you the governing equation. You feed it motion of a pendulum, it'll give you Newton's laws. So thinking that you can expand that beyond that to, parameterizing data you extract from food, it's definitely doable. It's just a matter of how much economic value is there and how much automation, and how much do we understand the process. Right? The more we understand the process and the more value there is, the more we can automate it.
That's true. That's true. So I want to get to another question, and it's not specifically related to food printing, but to me, open source is pretty important in my own designs. And obviously, I wouldn't be talking to you or to any of this point where I'm at now without open source hardware, open source technologies, open source software, and just people being open with me about everything in the community around RepRap and everything. And what's your thoughts on open source and its relation to food and
I think open source is useful, but it's limited in where it's useful. It's really useful when it is useful, but it basically comes down to it's one of two things, right? Either it's FUBU engineering, right, for the user by the user. It's Ubuntu is designed for CS majors. Arduino is for electrical people. It's the community exists because it's designing for itself. And paying people to design for other people, or getting people to design for other people where they're not the user, you pretty much have to pay them because they're not interested in contributing and volunteering for it, right? So I think open source is really good when you're designing, the community is designing for itself, or when you have companies that are backing something open because no one can make money off of it directly, but everyone needs it to exist. Anytime it's not one of those two conditions, probably corporate work is going to be better, just because when there's financial interests, people will pay more to do better work, and you'll get a higher quality out than from open source. In the cases where you are designing for the user community itself, you tend to get a better result from open source. So I would say, you know, if you look at the web standards, right, Apache is better than Microsoft's version. You know, it works better that way. But you know, if you say if I tried to make an open source car, is it going to work better than a regular car? Probably not. And even though people have tried it, there are limitations in where open can fit. Where it does fit, fantastic. Where it doesn't fit, I'm a little skittish.
No, that's thanks for sharing your point of view on that. It's interesting for me to hear a lot of people's perspective on it, because for myself, I obviously wouldn't have learned it, you know, anything of what I've learned about 3D printing so far, and I try to share everything I learn with them. And although the BOPQ is nothing that's going to change too many lives, you know, I make it open so that in case it can inspire anybody to do something else or take something a step further, it can. So I just wanted to get your perspective on it. Thanks for sharing that.
Yeah. Oh, I think his microphone's off.
You're muted.
He's gone mute.
Okay, no. It's me that I'm muted. So, another thing that I'm curious, and I think nobody can, like, really few people could say that, is like the Fab at Home printer has been out already for a few years.
Mm-hmm.
I'm sure you guys have been selling a bunch of them. Actually, as far as I think even Google had one of your printers in their headquarters, in their canteen, preparing food and so on. I'm really curious if you, obviously, I don't think this scales too much, but if you having this feedback from a lot of people is really useful. So I wonder if you guys had some way to manage these, or it was more like a one-to-one case thing, like.
So when the Fab at Home project was in full swing, it was run almost entirely by undergrads here at Cornell. And so Evan launched it and then just gave it out to the world, and then shortly thereafter graduated. And so when we took it over, we turned to an undergrad project team. And so we got quite a bit of feedback from users. And actually at that time, most of our users weren't food, they were biologists. And the number one feedback we were getting was about the motors. That on the Model 1 kit, most of the tech support requests we got was because we had them screw the motors into terminals with the wires, and they would do it wrong, and they would fry like a $120 motor. So we ended up switching to these motors called snap motors because they were impossible to plug in wrong. They were Cat5 cabling. We figured anyone could plug in Cat5 cabling. And we redesigned the entire thing with IKEA in mind. We actually had a mandate that we could use no glue. Everything had to fit in place and screw together, and could only be done with a hex wrench. And in our Model 2, we didn't quite get there. We still needed thermoplastic inserts. In Model 3, we finally got there. But that was basically the feedback was, you know, our users were biologists. Biologists aren't mechanical or electrically trained. And so we had to eliminate as much of that as possible to make it easy to use. We didn't have any organized mechanism for feedback because we were just 40 undergrads working on this thing in our part-time. So we just kind of figured out what we wanted, ran it by Hod, and he said, yeah, that sounds good, and then we went out and did a revision. We never quite developed not even quite. We never developed the community that RepRap did, mostly because our utility wasn't there. We were great at research machine. That's what we were originally conceived of as. We gave it out to the community, but we were still a great research machine, while RepRap was a useful tool for makers. So a useful tool for makers got a community around it that self-supported it. A research tool got a bunch of users who were researchers demanding new features and abilities and would modify some things themselves. But it was kind of the limit of our feedback and community support. The other problem we ran into was kind of related to the bio community. They don't like to share all of their secrets. The bio community likes to hold on to just a little bit of their magic sauce when they talk about their work. So sometimes when we've been working with people, like, well, what material are you working with? They're like, I can't tell you. It's just kind of this mentality of they're going to hold back because they're going to publish a paper about this, so they don't want us scooping it because we know the technology better than them, and they're afraid, well, if I tell them I'm doing this, they can do it in an afternoon, and there goes my paper. So supporting scientists is very, very different from supporting makers because sharing is an important part of the scientific process, but it comes at the end. It doesn't come in the middle or during, and it really changed the nature of the community.
I think that's something really cool that, and I think something that I got from you from the talk is like you really in order to put outside a great product, you need to understand who you are marketing, and depending who you need to act in a way or another, no? And this, for me, this is really interesting. The difference between a research audience compared to a makers or compared to a chef's audience or customers, it brings completely different set of needs and requirements.
Mm-hmm.
And that, for example, I think is really cool in terms. I don't know how the Fab at Home works nowadays. Is it still a kit or is a built printer that they just plug?
So Fab at Homes are still a kit. They're sold through Seraph Robotics, and they're pretty much the sole producer and supplier of them now. We really reached a point in 2011 where we kind of looked at Hod and myself and we said, I don't think we can get another paper out of this. We had a big paper on Fab at Home Model 1 that got a lot of attention and a lot of warm regards in the academic community. Model 2, we got a pretty good reception at Solid Fruit from Fabrication Symposium. Model 3, we did again and reached a point where we have 50 undergrads that we're all cramming onto one paper, and that's essentially how we pay them, is with academic credit and papers, and we can't get papers out of building printers anymore, so we kind of shut down the team because it was no longer really something that an academic institution should run. There's kind of a limit on what's appropriate for the academy, and running a project to design and develop 3D printers was useful in 2005 through 10. Now, it's not really something to write a paper about.
Okay. It's really interesting.
Yeah, it is. So what are they working on now?
Well, Hod's working on moving to Columbia. That's the big thing. So our lab is actually in the process of shutting down here at Cornell, and Hod's going to move it to Columbia. So we don't have that many undergrads around right now because, second semester seniors aren't that interested in really doing anything. And younger students aren't really that interested in joining a lab that's about to close. So we don't have too many people around right now. But our lab as a whole has kind of shifted focus from, developing machines to developing materials and developing new applications. So probably the work that you're going to see out of Hod in the future and out of this lab in the future is going to be application-driven. So find a use for 3D printing, describe how to solve that, how to apply 3D printing for that application and how it improves that application. And actually, as a whole, you're seeing 3D printing is getting really good at application-driven results. And that's really the big question right now. It's, we can print a lot of things. How do we make it useful?
That's right.
I think that's really smart move. It's what we need. We need more applications, less 3D printers.
Well, what's funny is, I remember when 3D Systems started with their 3D printer for the kids' room, right? That was the idea behind the Cube, the original Cube Model 1. It was going to be a kid's toy, $1,000 hot plastic gun kid's toy. Kind of didn't work out that way, and really the market as a whole has shifted since I've been in it from we're going to make a 3D printer in everyone's home shooting out plastic tchotchkes to we're going to put a 3D printer on every engineer's desk so they can do work faster. But the real success of 3D printing right now is actually the metal printers at the industrial scale, producing fully functional parts, doing incredible things. No one gave it any media attention whatsoever, and it's probably having the most transformative effect right now. Other printing processes are going to have that, time in the sun as they become more and more useful to existing industries. But some of them are further than others, and probably food printing right now is probably the furthest from truly being disruptive to other industries. But it has a lot of potential if we get it right.
I think I saw some stuff at the Euromode back in November with the metal 3D printing, and my mind was blown to see what they can do. There was a new machine from 3D Systems there that was the size of my apartment that was doing some amazing work. There was several other manufacturers there, and it was amazing to see that stuff going.
Yeah, now we just need to get there for food printing, right? One the size of a room that can pump out, 1,000 meals for the U.S. Army. And I think if anyone is going to drive food printing furthest, the fastest, it's going to be the U.S. Army.
Yeah.
If I had to put my money anywhere, it would be them saying we want to eliminate chefs on the battlefield, and they drop $20 million on R&D, and 2 years later you have the robotic chef.
Yeah.
And that's kind of, especially being in the academy here in America, that's how it works, right? We do some good work on other funding sources, but every once in a while the military just decides, no, we need to solve this. And when they decide we're solving this, it gets solved, and it goes all over in terms of its bleed back into society.
Yeah. Yeah, that's the truth. That's the truth. I've seen it in action.
It's scary, right? When DARPA decides we're doing something, okay. Right, $1 billion here, $1 billion there. Before you know it, you have a solution to a problem. It may not be the one problem you started out with, but it's a solution to a problem.
Yeah, that's exactly right.
Okay. Do you guys have any other questions I can answer?
Yeah, I got another one. So what's next for you after the PhD?
Vacation, sleep. That's what's next. I can't even look up. I've got too many pages to write between now and then. Yeah, I don't know. A lot of work. More work and a nap. That's my plan.
That's a good plan.
Yeah.
That sums up my questions, Louis. I don't know if you have any more.
I don't have any more. I just wanted to double confirm. Jeffrey, are you going to Holland this month?
I am fortunately not going to Holland. I'm going to be presenting there remotely. Actually, I'm going to teach a class in Italy the following week, so it was a little bit too much travel to do both and write a thesis and all the other things.
Well, that's a shame because both of us are planning to go. We'll both be there.
Do you guys know of any remote presence company that you can rent a robot from? I know they have them in the U.S. I don't know if any in England or the Netherlands.
I'm sure I could try to dig something up.
Yeah, if you guys know of any, let me know, because I'd love to just remote in, instead of flying for a day there and a day back. being an iPad on a Segway would be pretty cool for a change.
I'll look some up and
That
I'll
sounds
see
nice.
if I can get some.
Okay.
Well, thanks so much, Jeffrey. It's really been an honor for myself, speaking for Lewis as well. I'm sure it's. I think for me, this was probably one of the most important interviews we've ever done. You were a big inspiration for myself, at least, reading from your work and reading all the interviews that you've done and everything. And I think you're a big part of why food printing where food printing is at right now is the food maker community, such as myself. But even more, I think you're going to have a huge impact on the industry. So
Thank you very much.
if you want to say anything or read more of your work, where should
Yeah, if you want to read up more on our work, check out the Creative Machines website for now at creativemachines.cornell.edu. There's the Fab at Home website, of course, fabathome.org. And I don't know, set up a Google News alert. That's probably the best way. That's what my mom does.
Well, thanks again, Jeffrey. It's really been an honor, as I said, and I'll let you know as soon as I find a presence robot here in Holland. And have a safe travels in Italy, and good luck on your PhD.
Okay, thank you very much. Have a great day.
Okay.
Take care.
Bye.